and welcome to Dove Biology, Apes Lessons to Go. In this video we'll be exploring renewable energy. The sun is considered to be a perpetual energy resource, and it's a great source for potential renewable energy. One way that we can apply the sun's energy is with passive solar heating. A passive solar heating system will absorb and store heat from the sun directly within a structure without the need for pumps to distribute the heat. By orienting our buildings on their site such that we can make better use of the summer and winter sun. One way that we can do that is by having a heavily insulated ceiling and north-facing wall. When the winter sun hangs low, we can maximize that heat to keep our homes warm in the winter. But as it is higher in the summer, by having that super insulation, it's going to keep that hot air out of the home. Another passive design is using a attached sun space or solarium. Here we're able to capture the heat of the sun such that it can keep the home warm in the winter and cool in the summer. By perhaps producing an earth-sheltered home, this will allow for super insulation, which will keep our home cool in the summer and warmer in the winter. Another application of solar energy is an active solar design. One way to use active solar heating is to pump a heat-absorbing liquid through collectors on the roof or special racks that face the sun. The heat then can be used right then or stored in insulated containers for release as needed. A great application for this is a solar water heater. So that we can heat the water using the sun that we use as we take our showers. A more extreme application of active solar heating is by using solar thermal systems. These will concentrate and transform the energy from the sun into high temperature thermal energy to heat water. A small scale solar thermal system can actually be used to cook food, which is a great application in a developing country where fuel sources are low or very high polluting. Large-scale systems can actually produce steam to make electricity. So here, all of these parabolic mirrors are concentrating the heat energy of the sun into a body of water, which is then going to turn into steam, which will turn a turbine and then produce electricity. Another way to produce electricity with the sun is by using solar cells. Solar energy is converted into electrical energy using specialized panels called photovoltaic cells. Now, the solar cells themselves have no moving parts. They're safe and quiet and produce no greenhouse gases. Solar cells can actually be used in rural villages that have ample sunlight who are not connected to an electrical grid. This allows for small-scale refrigeration for maintaining medicines in the villages, as well as the prevention of spoilage of some food items. Now, despite their benefits, several things limit the use of solar energy. Currently, the low efficiency of photovoltaic cells make it very difficult for us to use that as a primary source of energy. Also, the sun only shines during a portion of the day, so we need a backup or a storage system for holding all of that energy. And currently, unfortunately, our battery systems aren't efficient enough to really make use of all of that ample sunlight that we have throughout the day. Additionally, the high cost of solar cells is a major problem to their adoption. Mass production of more efficient designs may make those solar panels cheaper. Now, if scientists and engineers can learn how to efficiently use solar energy, we can actually use them to split water and produce hydrogen. This will set in motion what is thought to be called a solar hydrogen revolution. With hydrogen-powered fuel cells, we could use those to power both vehicles and appliances. Another good renewable resource, potentially, is using moving water. Water flowing in rivers and streams can be trapped in reservoirs behind dams and then released as needed to spin turbines and produce electricity. Additionally, energy from ocean tides and waves can be captured and generate electricity. Right now, there are only two large tidal energy dams that are currently operating, one in Lorance, France, and Nova Scotia's Bay of Fundy. With the movement of the tides each day, the water is then forced through an impeller, which then is going to drive a turbine to generate electricity. Now, there are some disadvantages of using moving water. And damming rivers will disrupt the natural flows and damage ecosystems. You might remember the original controversy between our conservationists and preservationists when they dammed Hetch Hetchy. There is little room for expansion in the United States. Dams and reservoirs have been created on just about 98% of suitable rivers. So we've kind of reached our maximum. And some scientists believe that we actually have exceeded the amount of damming, because you recall the Colorado River is so overdammed that oftentimes the flow doesn't even reach the ocean. Additionally, ocean tides and waves aren't expected to provide much of the world's electrical energy needs due to the high cost and the lack of suitable sites for installation. Another great potential renewable energy source is going to be wind. Wind power is actually the world's most promising energy resource because it's abundant, inexhaustible, widely distributed, cheap, clean, and emits no greenhouse gases once the turbines are installed. Much of the world's potential for wind power remains untapped. Capturing only 20% of the wind energy at the world's best sites could meet all the world's energy demands. Wind turbines can either be used individually to produce electricity, or they can be utilized on interconnected wind farms. Interestingly, the United States once led the wind power industry, but Europe now leads this rapidly growing business. European companies manufacture about 80% of the wind turbines sold on the global market. The success of this has been aided by strong government subsidies. Now, wind power isn't without its downsides. Some areas with the greatest wind is often far away from populated areas, which makes it difficult to transmit that electricity long distance. Wind can sometimes die down. Wind turbines are also been found to potentially kill birds and bats. Turbines can also disrupt the aesthetic view of mountaintops and coastal areas, and certain designs can be more noisy than others. So some folks would rather not have a wind turbine in their neighborhood. That whole concept of not in my backyard, or NIMBY. Another non-renewable resource is biomass. Biomass consists of any kind of plant material or animal waste that can either be burned directly as solid fuel or converted to gaseous or liquid fuel. Biomass is burned mostly for heating and cooking, but also for industrial processes and for generating electricity. Motor vehicles can run on ethanol, biodiesel, and methanol produced from plants and plant wastes. Here we have a Volkswagen that's actually been converted to run on methane produced from the breakdown of human waste in a wastewater facility in England. In this image, we see a group of young ladies producing fuel to be burned for cooking used out of elephant poo. Biofuels have several advantages. One, the crops that are used for production can be grown almost anywhere. There's going to be no net increase in carbon dioxide emission because the carbon dioxide was captured in photosynthesis and then released as a result of the consumption of that fuel. They're widely available and easy to transport. And oftentimes it can make better use of waste materials. For example, if a furniture factory has scrap wood, instead of putting that in a landfill, that could then be burned for electricity. Waste that's coming from home, municipal wastes, can actually be burned in a waste-to-energy factory, and then a smaller volume of waste is put into the landfill. So we're making better use of what is left over. There are several disadvantages for using biomass. Growing crops for biodiesel could potentially promote deforestation and reduce biodiversity if the popularity of biodiesel increases. Biomass plantations can deplete the soil of key nutrients if proper agricultural techniques aren't employed. Corn-based ethanol production requires a lot of water and nitrogen-based fertilizers that produce nitrous oxide, a greenhouse gas. Additionally, these crop-based biomass sources displace food crops and increase the prices of food. So perhaps rather than using corn as our source for ethanol, which is a food crop, we can use non-food crops like switchgrass or algae for the production of ethanol and biodiesel. A final renewable resource that we'll look at is geothermal energy. Geothermal energy consists of heat that's actually stored in the soil, underground rocks, and fluids within the Earth's mantle. We can use that geothermal energy stored in the Earth's mantle to heat and cool our buildings and to produce electricity. A geothermal heat pump can actually heat and cool a house by exploiting the difference between the Earth's surface and underground temperatures. The house is heated in the winter by transferring the heat from the ground into the house. The process is reversed in the summer as the warm air in the home is transferred to liquid, which is then circulated underground, and the cooler ground liquid then is going to be brought back into the home, and then air blown over that cooler liquid will then cool the home. Deeper, more concentrated hydrothermal reservoirs can be used to heat homes and buildings and generate electricity at a much lower cost and with much less environmental impacts than coal or natural gas. A disadvantage of geothermal comes from one of two problems. It's kind of expensive to tap large-scale reservoirs. And some geothermal reservoirs could actually be depleted if their heat is removed faster than natural processes can renew. Now, recirculating water back to the reservoir could slow this depletion process. Throughout the course of human history, we've seen an ever-increasing demand for energy. As we've moved forward, we found different sources of energy to meet those demands. Many of those have been less sustainable, non-renewable forms. A more sustainable energy policy would allow for us to improve energy efficiency, rely more on renewable energy, and reduce the harmful effects of using fossil fuels and nuclear energy. Many proponents say that we will need to have a shift from large, centralized macro power systems to more efficient, smaller, decentralized micropower systems so that we can meet our energy demands and have sustainability well into the future.